Okay, so we're going to move on to chapter 5, which is inequalities. And the first two sections we're going to go over are just solving some simple inequalities using the different operations. So addition, subtraction, multiplication, and division. We will also be graphing inequalities in one variable, which will represent the set of points that are all of the solutions of the inequality. And just as a reminder, equivalent inequalities are inequalities that have the same solutions. Now let's talk about when we graph an inequality for a minute on a number line. So first of all, we do have the less than inequality sign, right, which is going to be written like this. We also have less than or equal to, which is the same thing but written with that little line underneath. Then we have the greater than sign, and that is read from left to right in this direction. And we also will have the greater than or equal to, where you have the line underneath. Now, when you go to graph it on a number line, the less than sign will be an open circle on the number line, and the greater than will be as well. But when you have the equal to line underneath, you would have that filled in circle on the number line, and then the greater than or equal to would also give you that filled in sign, or the filled in circle on the number line. So let's keep that in mind. Okay, so you must be at least 5 years old. Now here's another terminology here. When we talk about at least 5 years old, that means that you have to be 5 or older. Right, so we have to be careful, because even though it says at least, and we might be thinking less than, it's actually x is greater than or equal to 5. Because if you can be 5 years old to go to kindergarten in Pennsylvania, but you must be at least 5 years old, that means you can be 5 or anything greater than 1. So this is what our inequality would look like. Now this is how we would write it with the variable on the left-hand side. However, it could also be rewritten to have the variable on the right-hand side. Now notice in both of these options, the inequality sign is opening up towards the x, and it is pointing, or kind of that little arrow point of the inequality sign is sort of pointing towards the 5. So these are equivalent inequalities here. Now when you go to put it on the number line, you just need this cutoff number here, which is the 5. Now you always start out by putting a point on that spot or an open circle, but because we have that equal to line underneath, because you can be equal to that age, you would want to fill that circle in. We sometimes call that a closed circle or a filled in circle. And then since we want our graph to represent all of the ages of someone that could go to kindergarten, that would be 5 or more, right? Because it says at least 5. So we would want the side of the number line that would contain all of those other values that are greater than 5. So that would be on the right-hand side. So let's write and graph an inequality that describes this situation. An infant car seat is designed for babies and toddlers weighing less than 40 pounds. So the weight would have to be less than 40 pounds. And this time it's not an equal to. Once they hit that 40 or go over, they're no longer eligible for this particular seat. So this would be how you would write the inequality with the variable on the left, or the equivalent inequality with the variable on the right would be written as 40 is greater than W. And then when we go to do the number line, our cutoff number is 40. It's only going to be an open circle this time because there's no equal to. And W is less than 40. So all of the other acceptable weights, maybe 35, 30, 25. I think I said less than 30 back then, but clearly it's less than 40. Those weights will be represented on the left-hand side of that 40, so the arrow will go to the left. Another example, a sign on a store display says items are $4 or higher. So that would mean that all of the items in the store would have to be greater than or equal to or on this display would be greater than or equal to $4. So we have our cutoff value, the 4. It's going to be a closed circle this time because things can equal to the 4 also. And since everything's going to be greater than or equal to that 4, that would be to the right. This would be how our inequality would be represented with the variable on the left. However, if the variable was written on the right, 4 is less than or equal to x, that would be acceptable as well. Now, when we look at a graph and we want to write the inequality from the graph, we need to find a couple things. Well, obviously, we need the cutoff number. So in this case, wherever that circle is, that's our cutoff number. We need to look to see if that circle is open or closed, because that'll tell us if our inequality sign will have that equal to line underneath. And then we have to decide which way our inequality sign is facing. Now, the way I kind of typically will do this is I'll look at the shaded part of the number line, and I'll know that that represents my variable. So x could be any of these numbers over here, and that is on the left of the 1. So it's always going to point to the left if you're looking to see which one is less, right? So whatever's on the left is less, so it's going to point to that and open up towards the one on the right. Now, this would just be x is less than 1 because there's no filled in circle, so I don't need the equal to. The other way this inequality could be written would be 1 is greater than x. If you happen to have it that way, that would be correct as well. All right, so let's take a look at this one here. So I'm going to look at my cutoff number, which in this case is a -2. Now this time, all of my graph that's shaded here is on the right. So my x is on the right of the -2. Now, again, if I'm looking at this visual, the -2 is less than any of these values for x. So that's why my symbol is pointing to the -2 and opening up towards the x. So this would be one way I could write my inequality sign here. But if you really want to write your variable on the left, as some people do like to do, we know that since this arrow was pointing this way, it would go in that direction. X is greater than -2. So either of those would be okay. Again, it was an open circle, so there's no line underneath that inequality sign. Okay, and then over here, we have our cutoff number of 5.5, and all of the shaded part here is on the left. So x is less than 5.5, except this time I have to put that equal to line underneath because I have a shaded or closed circle at the point 5.5. Okay, so now when we go to solve an inequality, we can solve it using addition, subtraction, multiplication, division. Now this is just a simple inequality where we have x minus a number. So we're going to use the inverse operation here of addition to get that variable by itself, just like we would if we were solving something with an equal sign. Now at this point, we're going to have that less than sign just stay exactly the way it is, carry it down just like I would if I had an equal sign. 2.8 plus 1.3 is 4.1. So my answer here would be, or my solution would be that x is less than 4.1. To graph it, I put my 4.1 with an open circle on my number line, and x is less than 4.1. All the numbers less than 4.1 would be on the left. Example 4, another similar problem. This time I have x plus 4. Now notice this time my variable is on the right. It doesn't change how we go about doing anything. I still want to isolate the variable where it is. So I'm going to subtract the 4. Now on this side, 13 minus 4 is 9. And then over here I'm left with just this x. So this would be my answer. However, some people prefer to have the variable on the left because it makes it a little bit easier for them to graph on the number line. That's fine. You can reverse it. However, the direction of the sign still has to point to the same thing and open up to the same thing. So it's still got to point towards the 9 and open up towards the x. So if you reverse the two sides of your variable and your number, then you also have to reverse the direction of your inequality sign. So now we know we have a closed circle at our 9, but x is greater than or equal to 9. So that would be to the right. Now, if you want to use a little directionality kind of clue, as long as your variable is on the left, you can kind of see which way this inequality sign is pointing. Like the little pointy part of it almost looks like an arrow that's pointing towards the right. So I knew to make my arrow to the right. However, if you looked at the original answer we had, it wouldn't follow suit because the x was on the right-hand side. So you can use that little directionality cue, but only if your variable is on the left. So I prefer to usually just check with a number, and I say to myself, like, okay, what's a number that's greater than or equal to 9? Like 10 or maybe 11, and I just make sure those numbers are on the side of the number line that is shaded. All right, so let's do a couple practice problems with this. So to get my x by itself, I'm going to add the 7. That will give me x is less than or equal to positive 4. I'm going to put my 4, which is my cutoff number, on my number line with a closed circle. And x is less than or equal to 4. And the numbers less than or equal to 4 would be on the left, such as 3, 2, 1, and so on. The next example, I have a y on the right-hand side that I'm going to isolate. So I'm going to add the 2.7 to each side. So 5.1 and 2.7 is 7.8, and that's greater than y. Now, you may certainly leave your answer like that, or if you want to write it with the variable on the left and the 7.8 on the right, that's fine, but you have to also reverse the direction of that inequality sign. So now my 7.8 with an open circle, since I do not have the equal to line underneath, is going to go right there. And y is less than 7.8, so I'm going to the left. Okay, the next one, I want to get that z by itself right where it is. So I'm going to move the 9 over by subtracting it. So I have z is less than negative 10. The negative 10 is going to go on my number line since that's my cutoff number. And I have an open circle there. And z is less than negative 10. And all the numbers that are less are always on the left. Number 8, I'm going to keep the w where it is on the right. And I'm going to move my 1.5 over by subtracting it. So that gives me 4.5 is less than or equal to w. Now this is one of those situations where I might want to rewrite my answer as the equivalent inequality that just has my variable on the left. Making sure if I do that, I also change the direction of my inequality sign. So now I have that cutoff number of 4.5 on my number line graph. I'm going to do a closed or filled in circle because of my equal to. And w is greater than or equal to 4.5, and the greater numbers would be to the right. So now let's talk about multiplication property of inequalities. So when we multiply each side of an inequality or divide by a positive number, it's going to produce an equivalent inequality. So it's not going to change the sign. However, if we multiply each side of an inequality by a negative number, we are then going to have to reverse the direction of the inequality symbol in order to produce an equivalent inequality. And this also goes for division as well. So if we take a look at the first example here, right now I have x being divided by 7 on one side of my equation and the 3 on the other. Well, the opposite of division is multiplication, so I'm going to multiply both sides by positive 7. Since I'm multiplying by a positive 7, I don't have to worry about my inequality sign changing. I'm just going to have x is greater than 21. The graphing is the same. Put that cutoff number on your graph. This time will be an open circle. X is greater than 21, so we are going to the right. Now the next example, This time I'm going to multiply both sides by a -2 in order to get my x by itself. But because I'm multiplying by a negative value, I have to change or reverse the direction of that inequality sign. So I have x is greater than or equal to that -10. Close circle because of the equal to. X is greater than or equal to -10. Greater numbers are to the right. Now when we look at the next three examples, if I take a look at number 9, I'm going to multiply both sides by 4 to get my m by itself. Now, some people will look at this and they'll say, oh, but I have a negative, so I'm going to have to flip the sign. But you don't, because you're not multiplying both sides by that -3. It just happened to be a negative. You're multiplying by a +4, so your sign is not going to reverse or be flipped. It's going to stay exactly the way it was. So your answer would be m is less than that -12. So then when you put it on your number line, you just have that open circle at the -12, and the numbers that are less than -12 would be to the left. Okay, number 10, this time we are multiplying both sides by a -6. So this time we will have to change the direction of that inequality sign, and we get -24 for our solution. So our cutoff number here is -24. And after we reverse the direction of our inequality sign, we end up with n is greater than or equal to -24, and all the greater numbers are to the right. And number 11, we're going to multiply both sides here by -1.2. So, of course, I'm going to have to reverse the direction of that inequality sign once again, since I multiplied by that -1.2. Just so happens on the right, I had a negative there already, so when I multiplied it by another negative, I ended up with a positive 9.6. So when I go to graph this on my number line, I'm going to plot the 9.6. It's going to be an open circle, and P is less than 9.6, and the less than numbers are always on the left. So now when we use the same concept here with the division, so 6 times x is greater than -36, so I'm going to divide both sides by 6. Now, just like we did on that other example, I did not divide by a negative here, I just divided by a positive, so my inequality sign is going to stay the same direction that it originally was. My answer, however, is a -6. It's going to be an open circle because there was no equal to line underneath my inequality symbol. X is greater than -6. The greater numbers are to the right. Okay, number 12, dividing both sides by a -3. So this time, because I did divide by a negative, I have to change or reverse the direction of that inequality sign. So I should have x is greater than or equal to -3. Now I can plot that -3 on my number line, do a closed or filled in circle, and x is greater than or equal to -3. Greater numbers are to the right. Number 13, I'm going to divide by the 9. Be careful, you always want to divide by the number that's next to the variable to get that variable alone. 18 divided by 9 is 2. Divided by a +9, so I do not need to reverse or flip my inequality sign. So I ended up with 2 is greater than or equal to x. Now, if you don't like having the variable on the right and you want to switch it, that's fine. Now you reverse the direction of the inequality sign, so that it's still pointing to the x and opening up towards the 2. So when I graph this on my number line, it would be a closed circle at the 2, and x is less than or equal to 2, so that would be on the left. And then for number 14, I'm going to divide both sides by a +6, so I don't need to change my inequality sign. I'm just going to leave it as x is less than 2. When I go to graph that, I'm just going to have an open circle at my 2 this time, and then I will still shade to the left. So just a couple real world problems. So this one here, we have a library has $180 to buy new books. The books cost $9 each. Write and solve an inequality to find the possible number of books that can be bought for the library. Okay, so the way to think about it, anytime you're going to go shopping, you're kind of using an inequality situation because you always have a certain amount of money, right? And the amount of money that you have, you can only spend less than or equal to the money that you have, right? So if I'm going to spend money and the books cost $9 each, in this case, I'm going to have 9 times B, however many books. And whatever that total is, it has to be less than or equal to the money that I have to spend, or in this case, the money that the library has to spend, which would be $180. So now if I go ahead and I want to solve this, in order to solve it, all I have to do now is divide by the 9. And I would get B is less than or equal to, and it would be 20. But what is the 20 representing in this case? Some people were thinking it was dollars initially, but be careful. A library has $180 to buy new books. The books cost $9 each. We divided that, and we are left with 20 books. So the most amount of books that we can buy are 20. Do we have to buy 20? Can we spend less than the $180? Sure. Can we spend more than that? No. All right, so let's take a look at this one. So we're going to do the same example, except this time we have $120 to spend, and the books are only $8 each. So $8 times the number of books is less than or equal to 120. Then we're going to divide the 120 by the 8 to see what is the most amount of books we can buy. 8 goes into 12 once and go over there. So it would be 15 books. That would be the maximum amount of books that we could buy with that amount of money at that price. Okay, and then finally, 3 sisters want to buy an iPad for their father for Father's Day. The least expensive iPad is $360. Write and solve an inequality to find the least amount of money each girl would have to contribute. So we have 3 sisters, and they're each going to spend X amount of money, right? They're each going to spend so much money. And all of that is going to be greater than or equal to the $360 that the cheapest iPad costs. So they might even spend more than that. But if they're going to buy an iPad, they're spending at least $360, which means $360 or more. So the 3 sisters times however much money that they each spend separately will be greater than or equal to 360. So 3m is greater than or equal to 360. So if we divide the 360 amongst the 3 sisters, we end up with $120 each. So the amount of money that each sister will spend will be $120 each, but it could be greater than or equal to $120 if they change their minds and buy maybe a more expensive iPad.